Okay, let's talk combinations. A basic definition of the number of combinations would be the number of ways to take R objects from N objects when not considering order. Okay? And there are several ways to represent this. A popular way on calculators would be NCR. Another way would be combination N comma R. Some books they'll use kind of this method, and others maybe even use something like this. Okay? But all of these have the same formula. That would be n factorial over r factorial, and then n minus r factorial. Um, Now let's do a simple example. Let's just do combination 3, choose 2. If I use the formula, that would be 3 factorial over 2 factorial, and then 3 minus 2, that would be 1 factorial. 3 factorial is 6, 2 factorial is 2, 1 factorial is 1. I'll just do 2 in the denominator. 6 over 2 would just give us 3. Now, of 3 objects taking 2 at a time, I can do that in 3 ways. So let's do a bit of a more concrete example. N objects, 3. Let's just do A, B, C. And then we can list out the ways to just take 2 without regard to order. So one way would be A, B, and this would be the same as BA. Order doesn't matter. I could do AC, and then lastly, I could do BC. So there we have our 3 ways. Okay? So now that we understand a bit more about what combinations are, let's do a few problems. Okay? First problem I want to talk about, how many hands of poker contain all clubs? So here there are 13 clubs in a standard deck of 52, and 5 cards in a hand. Now, when I have those 5 cards, they're not necessarily in any particular order. I just have them in my hands. Okay, so this would indicate a combination. So here, combination of the 13 clubs, choose 5 of them to be in my hand. Now, I'm not going to go over the gritty details of actually calculating this. I just would suggest using a calculator. So whatever calculator that you're using, see if you get the same numbers that I'm coming up with. So here, 13 choose 5 would give us 1,287. Okay, simple enough problem. Let's look at another one. So at an ice cream shop, you want a 3-scoop dish of all fruity or all savory flavors, all different scoops. There are 6 fruity and 5 savory flavors that the shop offers. How many ways can you place your order if you don't care how the scoops are arranged? So here, let's jot down a few things. So one might be that we want 3 scoops, and that there are 6 fruity flavors, and then 5 savory flavors. Make that a bit more curly. Where is my cursor? There we go. Savory flavors. Okay. Now here, there's an option here. I either want my 3 scoops to be fruity, or I want them to be savory. And in combinatorics, when we're dealing with 2 ideas and they're linked with or and, we generally do different things. So here we have and, so I'm going to multiply. If it was, sorry, it's not and, it's or, so I'm going to add. If it was and, then we would generally multiply. Now for calculating the fruity flavors, I could do combination of the 6 fruity flavors, choose 3, or combination of the 5 savory flavors, choose 3. 6 combination 3 is 20. 5 combination 3 is 10. Add those up. That would give us 30 options. Okay? Let's look at a similar a problem, but for this one, it would not be using or, we would be using and. So here, in a musical, you want 8 chorus members with an even number of males and females. If 8 males and 5 females audition, how many ways can you form the chorus? So here I want an 8-member chorus, even number of males and females. So that would mean that I want 4 males and 4 females. What I have to choose from are 8 males and 5 females. So here, my 2 ideas that I would dealing with would be my male cast members, or chorus members rather, and my female. And here we do have and that pops up, but for here, one way that you can always tell is to try to link the 2 ideas and say it out loud. So here, does it make sense for my 8 chorus members to be 4 males or 4 females? Or does it make sense for me to say that my 8 chorus members will comprise of 4 males and 4 females? In this case, and makes more sense, so we're going to multiply. So calculating males, that would be combination of the 8 males, choose 4 of them. For females, that would be combination of the 5 females, choose 4. 8 combination of 4 is 70. 5 combination 4 is 5. Multiply those together. That would give us 355 ways to form our chorus. Okay? Last problem. How many ways are there to form a committee of 4 from 7 Democrats and 5 Republicans if you want at least 1 Republican on the committee? So here, this is an example of maybe a little bit more complicated question, at least compared to the previous questions. So here, I'm gonna kind of jot down what the question is, and I'm gonna kind of label it as our event E. Okay, so at least 1 Republican. Okay. So we want a committee of 4. We have 7 Democrats. We have 5 Republicans, and we want to satisfy that event that we want at least one Republican. So for this problem, I'm going to do a T-chart, and I fill it out completely. Okay, so this T-chart is going to describe all the possible ways that we can form this committee with respect to how many Democrats, how many Republicans on the committee. So I'm going to start off with the fewest number of Democrats. That would be 0. And if I had 0 Democrats, that means I would have to have all 4 Republicans. If I had 1 Democrat, that would mean that I would need to have 3 Republicans. If I have 2 Democrats, that would be 2 Republicans. 3 Democrats, 1 Republican. 4 Democrats, that would be 0 Republicans. Now here, I'm still going to fill out this entire chart that we'll talk about more later. Okay, and at this point, see if you can work ahead of me. Okay, so if at any point you feel comfortable, pause the video and try to fill out this entire chart. So for this first row, 0 Democrats, 4 Republicans. I could write that out in combination. Combination of the 7 Democrats, choose 0 of them. 0 Democrats and 4 Republicans, and so I multiply. That would be combination of the 5 Republicans, choose 4. 7 choose 0 is 1. 5 choose 4 is 5, giving us 5. Next row, that would be combination of the 7 Democrats, choose 1 of them, and multiply combination of the 5 Republicans, choose 3 of them. 7 choose 1 is 7. 5 choose 3 is 10. That would be 70. Next line, combination of the 7 Democrats, choose 2, times combination of the 5 Republicans, choose 2. 7 choose 2 is 21. 5 choose 2 is 10. 21 times 10 is 210. Combination of the 7 Democrats, choose 3, times combination of the 5 Republicans, choose 1. 7 choose 3 is 35. 5 choose 1 is 5. 35 times 5, 175. Last row, combination of the 7 Democrats, choose 4, times combination of the 5 Republicans, choose 0. 7 choose 4 is 35. 5 choose 0 is 1. 35 times 1, 35. Okay. Now, if I want to calculate this E, at least 1 Republican, I can look at my chart and note that my top 4 rows, all of these, those satisfy our event. Okay, so I could just add those all up. I could do 5 plus 70 plus 210 plus 175. And if I added those all up, that would give me 460. However, there is another way to do this problem. Okay, so here I can look at my that bottom thing, or my bottom row. That's what I didn't want. That's the opposite of at least 1 Republican. Okay, and so there's this trick of, if I summed up all the ways that would satisfy my event, and I add it to all the ways that wouldn't satisfy my event, that should total up the total number of ways of forming this committee. So that would be our sample space. So I could calculate E by taking the number, our total number of ways of choosing committee members, minus what I didn't want. Okay? So to do that, in total, we had 12 people to choose from. So that would be combination of the 12 people, choose 4, minus the case where we didn't have any Republicans. That would be combination of the 7 Democrats, choose 4 of them. 12 choose 4 is 495, and then 7 choose 4 was 35, and that gives us 460. Okay, so the same number of ways. Okay, thanks for joining me for my little thing on combinations. Until next time.